Good evening, everyone. Today's session is on stacks that we have in our data structures. So we will be learning about like what are the applications of stacks we have, how to have like how it is implemented in memory, or how the elements are saved, stored in memory, how we have postfix expressions, prefix expressions, we have different notations, how these expressions are evaluated using stacks, right? So using stacks we can implement the data structures that we have. Right. So what is a stack? Let us see. It is an ordered group of homogeneous items of elements. So when you are maintaining any stacks, it should be of same data type, right? Or you may say, the like if I'm taking the examples, you may be a stack of shoe boxes, you may be a stack of books, you may be a stack of shirts, you may be a stack of pennies, you may be a stack of trays, you may be a stack of spoons, you may be a stacks of bowls. You may There are number of things through which you can implement it, right? Elements are added to and removed from the top of the stack. So if you are maintaining the stack, you put one element, then put another element, then put another element, so your stack keeps on increasing. This is how stacks are implemented. Like suppose I am putting something here, right? I am putting here, then again putting something else, then again putting something else, then again putting something else. So elements are removed from the or inserted from the top of the stack. So the top of the stack is this thing, right? This is our top of the stack, right? The last element to be added in is the first to be removed, right? So the last element because we follow last in first out. So the last element that is inserted into the stack is removed first. Like we have the last element in the stack is this one. So if we want to remove, it is to be removed at the first. So we call it as LIFO, the order of removing the element, or you want to remove any delete any element, you may be following the order that is LIFO. Last in whatever last element you have added, that is first deleted. Now let us see some definitions, some of the key points, some of the key terms that we used in our operations, right? Provided max items, what will be the maximum number of items that might be on the stacks, like 10 items, 20 items, whatever item. So you need to specify the max of items. Item type, what is the type of item, what is the data type of the item? I told you it maintains the homogeneous collection. If I'm maintaining a collection of tray, so all this is not containing tray, bowl, or you may say a spoon or some something else, a book. No, all the items is of same type. If I'm maintaining some coins, I may be taking all the coins. If I'm maintaining the shoe box, I am taking all the shoe boxes. I can't take any other box, like your any box you may take it, you can't take it, right? Because you are maintaining the homogeneous collection of data, right? So what are the operations that can be performed on our stack? That is make empty, boolean is empty. So these are some basically for implementing the stacks we may have some functions, right? So what are those functions? These are that we have specified. What are the different operations? We may insert the element, we may delete the element. So for pop means deleting the item. Push means you are inserting some items into the stack, right? Now let us see how we have a push. Push means you are putting some elements into a stack, right? So the function is add new item to the top of the stack. Suppose I'm making a container, right? And in this container you are putting some, I'm going to share some examples also in the next slide. So this is how, like this is one item, this is two, this is three, and so on, right? So LIFO order means last in, the third item that I have entered, that comes first, right? So this is how it is maintained. And how we are adding from the top of the stack. So these are some uh, you may say concept, or you may say some uh, main things that needs to be followed while applying the stack data structure. Precondition stack has been initialized and is not full. If you are saying there are a stack can maintain maximum of 20 items, right, and you are inserting the element that is 21, will it be possible? No, na. So we must check out the precondition. You should initialize the stack and is not full also, right? If you have taken that much of size, that means there are some elements that are empty. Post conditions, the new item is at the top of the stack, means obviously new item, where your new item, because it follows what, like you are putting, you are adding the items from the top of the stack, right? So new item will be added from where? Not from the base, from the top of the stack, right? It is completely the opposite of queues, right? Now how to delete the item? The first, the last item is first to be taken out, right? So let us see. Function removes the top item from the stack and return it in the item. Preconditions, stack has been initialized and not empty. If you don't have any element in the item, what do you want to delete it? So these are the conditions which needs to be checked while applying pop operation. Post conditions, top element has been removed from the stack and item is a copy of the removed element. Now let us see how we have such kind of thing, like how we pop the elements and how we have the copy of that. So let us see, like first, yeah. So in the first part we have the empty stack, we don't have anything. Now we have to check for pushing the elements whether your stack is basically not having the maximum number of items, or your stack is not full, right? And pop may you are checking your stack is not empty. These two conditions must be verified before applying push and pop operations, right? Now you are inserting, now this is your top pointer. Top is basically pointing to the top item of the stack. Now you are putting 2, right? And then you are inserting another element that is 3, right? And then you are inserting 5, right? And then what you are going to do is, like, here we are again in these three conditions, what we have done, we have inserted 3 items using push condition. What are those 3 items? 2, 2, 3, and 2, 3, 5, right? Understood? Next part, now we want to pop the elements. Now we want to pop the elements. The element that is last inserted, which is the element which we have last inserted, that is the last element which we have inserted, that is 5, right? And after that we have inserted 3, and after that we have inserted, if we want to push anything, we may push after that. This is how we insert, we push the elements and we pop the elements, right? This is how we maintain our stack of elements. So again I'm repeating these steps. First you have taken the stack, right? In the first part you have inserted 2, in the second part you have inserted another element that is 3, in the third part you have inserted another element that is 5. Now if you want to pop anything, right? So with either you directly give the location, you may say item this should be popped, so you may do that thing also. Or if you are not doing that thing, the last in should be first out. Last in element is 5, it should be come out. Otherwise, in this case, like you have taken 3, then 2, 3, 5, and then you have popped which element? You have inserted again 10, right? So you may be specifying the top pointer that is pointing to what? 3 value, right? Again it is pointing to 2 value. Again it is pointing to, why it is pushing the value? Because last you have deleted that value, right? So it keeps on like increasing and decreasing based on your push and pop operations, right? So I will be using some syntax or some functions while implementing the stat data structure. So let us see. First of all, we have included one header file, that is item type, and then we have taken a class of stack type, right? Now in this we have specified the member functions in the this stack type class. First you have called the constructor, that is stack type. Then we have, I told you these are the different functions that we are going to use: make empty, is full, push, and pop operations. So these operations are called member functions of the stack, right? This is what we have initialized, right? So we have make empty, constant we have maintained, is full, and then push and pop. Push what item type, pop what item type, the address of that item. So you may have this thing, right? And the most important part, when pushing an element, check out the max part, whether your stack is full or not. When popping the elements, when you are pop some elements from the stack, make sure your stack is not empty. So these are the two conditions while implementing your stack part. Now let us see some how we call it as. So your top pointer is pointing, we have assigned the value that is -1, and make empty is again nothing is there, you have -1. And if it is empty, then it is going to return -1. Why? Because if we are having first time when we are implementing, or we are not pushing or pop any element, so we just check it out, we have the empty part or we have the maximum element. So both the conditions are checked. So let us see the maximum element condition also. If the stack is full, obviously you can't push any elements to that part, right? So max items, you may check it out, your top is equal to max minus 1. And when you push the item, you may increase the top, obviously, because top always maintaining the where from you are inserting the elements. So when you insert the elements into the stack, it should be from top of the stack, and when you remove the item from the stack, it should also be from the top of the stack. So basically what we are doing is, we are maintaining a pointer that is pointing to top of the stack. It is only doing everything in this program, right? Now let us see this very very important part, how you push an element to the stack. Now when we have checked all the things, suppose I am entering everything and I have done with everything, what you are going to do? First of all, when you want to increase or when you want to insert any element into the into the stack using push function, right? Then you just increment the top pointer, and whatever item you want to insert to the item, right? Whatever the value of the item, insert it the item's top means the last item which is added, right? Now the same thing is with pop also. Now when you are pushing anything, when you are adding anything, obviously you are increasing the pointer. When you are deleting anything, obviously you are decreasing the pointer. The same rule is followed. Like if you are taking out the shirt from that particular stack, so your numbers are decreased, the number of shirts are decreased, because you have taken out, you have popped that one item from that particular stack. And if you are adding one shirt to your stack, that means you are adding some thing to that stack. So when you are doing some addition part or some like pushing into the stack, that means you are adding You are incrementing the top pointer, right? And when you are pop some element from the stack, you must be decrementing the, yes, top pointer. And which item? That is obviously the item is at the top, right? Top pointer, top elements, the top items, and assign it to the item, and then decrement that pointer, right? Now next thing is to decrement that pointer. This is very very important while defining push function and pop function, right? So always remember this part. Push may you need to check out the maximum elements, the stack is not full. Pop may the stack is not empty. Empty may say what you are going to pop. If you have an empty stack of elements, what you are going to pop? There is nothing in the stack, right? And if we have the stack and stack is completely full, what you are going to add? So these two conditions are checked before in hand while using these two functions, right? Now let us see. Yeah. Yeah, so this is the thing which I was discussing. Stack overflow, there are two conditions. Stack overflow, the condition resulting from trying to push an element on the top of on the onto a full stack. Full stack means your maximum elements uh, limit is reached, and you are putting something into a that particular stack. So you can't do this thing. So you need to call this function, that is not stack dot full. Is full, is the function. If it is full, then no need, then you can't perform the push operation. If it is not, that's why this exclamation sign is used, and this is representing not any expression. So expression is stack is full, and before that we have not sign. Stack is not full, then you can push the item into the stack. If your that means like if the condition is true, if it is not full, then you can insert the element. But if it is full, if it is true, then it gives an error, that is stack overflow, right? Because you have the maximum number of items, you can't insert any item into the stack. Same as with underflow, right? Underflow means you have a stack that contains no element, what you are going to delete, what you are going to, what you are trying to pop from this particular stack, there is nothing in the stack. So here we need to use the function that is empty while popping the elements, while while trying to pop any element. So this is again is stack is empty, not stack is not empty. So you have again in this particular part, you have checked it for this condition is empty, right? And if it is not empty, you can obviously there are some elements in the stacks. There are some elements in the stack, something, and then you can pop it. If there is nothing in the stack, you can't pop it. So remember this thing, the points to be noted when you get the error stack overflow, when your stack is full. When you will get the error, that is stack underflow, when your data structure does not have any elements, does not have any items in the list, or you may say in the stack, right? So this is how we have different functions, and how, what do you mean by push, what do you mean by pop, why we use is full function, why we use is empty function, right? These are some examples on that. Let us see some examples. Postfix notation, you have some expression. Let us see how to implement with the help of stack, right? Postfix notation is another way of writing arithmetic expression. You may have some algebra kind of thing, or you may say some integer expression that needs to be solved, or some expression that is going to be solved using BODMAS. How computer is going to understand this thing? Let us start. In postfix notation, the operator is written after two operands. So like you have two numbers, these are the two digits. Post matlab after, pre matlab before, right? Pre basically what we used to have is pre pehle, post after, right? Now expressions are evaluated from left to right. So our expressions are evaluated from left to right. That's what we have in programming also. Precedence, rules and parentheses are never needed, right? So let us see, they don't have precedence or like this thing. We only evaluate the expression based on the expression in this. Expression means we have, if we want to evaluate through postfix, prefix, or you may have in order expression also. So let's take one example. You have this thing, 4 5 plus 7 2 minus into. Now how it works? Now in this particular statement, we have number of operators also, we have four operands also. How we are going to evaluate it? First of all, what we have done is we have taken the sum of 4 and 5, right? And then first of all, because it goes from left to right, we have already seen this part. Now 4 plus 5, done. Just write it down, 9 7, the rest of the things nines, like here what we have done, we have just evaluated this part, nothing else, right? After that 4 plus 5 is done, we are just taking it as 9, rest all is same, 9 7 2 minus and s multiplication also, right? We have multiplication also, that is left. Coming to the next part. Now once we have completed the first step, from left to right we have applied the operators also. Second operator that is coming under this series is minus. And what are the two numbers, two operands on which this operation is going to be performed? That is 7 and 2. 7, and which operator you are going to use? That is minus. 7 minus 2 is 5. So now here what we are doing, we are just evaluating in this part, we are just evaluating 7 minus 2, rest part is same, 5. Rest part means 9 and 5 would remain same. Now which operator is left? A multiplication. 9 5s are 45. This is how we basically post means baad mein, after. Two numbers we have operator, two numbers we have operator, then we can have other operators also. First we evaluate this, then get the answer, then we evaluate this, get the answer, then whatever the things are left, you may multiply or divide, whatever the operator is given, you may do it. So this is how it is evaluated. Now let us see how we perform this thing through stacks. First of all, from left to right we have 4, then we have 5, then we have plus. As soon as we receive any operator in the stack, we perform the manipulations, right? As soon as we have the operator in the stack, we perform, and two numbers also on which you are going to perform, right? So 9, we get the 9 answer. Then move to the next part, 9 7, right? Then 2. Now after 2 you receive one operator, yes. So here you receive the operator, that is minus. So you have maintained the elements 9 7 2. Now you receive the operator, perform the operations. That is 7 minus 2 is 5. Now your stack is again maintained like this. You have only single operator, right? Your operator that is left is multiplication. Just multiply two numbers in this stack part. 9 into 5 and get the answer. Or you may say here you will, after this statements you have the multiplication part, then just perform the multiplication of whatever, like it is multiplication, here it is given whatever the operator is showing, like plus minus jo bhi aa raha hai, you may take any of that, right? So this is how we have implementation of postfix expressions using stacks, right? Let us see the algorithm how to implement, or you may say a pseudo code for that. While more inputs item exist, get an item. First of all, you get the items. If item is an operand, yes, the main thing which I have shown you, item is an operand or number you may say, then you may put, if it is an operator, perform the operation. So let us see. If the item is an operand, just push into the stack. Else, what you are going to do? Else means if it is not an operand, if it is an operator, then pop it. How you are going to pop it? The first two, the last two elements, means last in for what we follow in this, the last in first out, the last two operands from the stack, we need to compute the what, we need to perform the, yes, operation, right? And then just take out the result. So this is how we implement the postfix expressions using stacks, right? What you have done, you have inserted number of operands. As soon as you receive the operator, you are going to manipulate, or you are going to perform the operation. Just get the operation, again keep on adding the elements. Once you receive the operator, stop and perform the operation. Then write the body of a function that replaces each copy of an item in a stack with another item. Use the following specification. This function is a client program. Replace item, stack type. I will be telling you how to have different programs, right, in our data structures, because they may be a complex type of structure. It looks like a complex structure, but as soon as you know the concepts, you can easily implement any of the specification. This is one example I have taken. You may have multiple examples. How to solve prefix expression, how to solve postfix expression, how to have such kind of specifications, like we want to copy this tag into another. We can have, basically it is not the typical one. It is just adding and deletion of items from the stack and performing the different operations on the stack elements, right? Because as we have seen in this part, we have different elements, right? We have different operations and on what, operands and operators. Again, I want to repeat one thing. Operators and operands, you should know. Operands are numbers on which these operations are performed. And what are these operations? Based on the operator, whatever the operator is given after that, after, because it's a postfix expression. So don't get confused with operand, operator, operations. There are three terms which we use in our stacks, in with other expressions also. Like if we are using prefix expression, or we will be using infix in order, yeah, infix notations, right? Operands are numbers, operators are plus minus, the arithmetic operators we have, and And the next thing is operation is whatever function you are following, that is operation, right? So hope you have understand the session, right? And you like the session. Thank you.